So what have we all learned from 6.1 to 6.4? Well, we've learned that we can label the quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And if I would pick one of them at random, and I would say quadrant 3, could you tell me which trait ratio is positive in quadrant 3? Tan is the one that's positive in quadrant 3, which means that sine and cosine are negative in quadrant 3. How do we know this? Our CAST rule tells us where things are positive. So I could give you an angle. If I gave you 125 degrees, could you tell which quadrant it's in? It's going to be in quadrant 2, and that would mean sine of 125 degrees is positive, but cos of 125 degrees and tan of 125 degrees will be negative. And we can use this idea to solve questions. So if I just pick one at random, if I say sine of theta is negative 1/3, and we want to solve for theta between 0 and 360 degrees, what would we have to do? It's going to be in quadrants 3 and 4. So we could draw a little picture of this. I find when I'm just starting trigonometry, I like to draw a picture. I like to go back to my nearest x-axis, because then that makes this my reference angle. Reference angles are very important. And in solving for this question, we have to find a reference angle first. How do we find the reference angle? With our calculator, but how?
Inverse.
So we have to do sine inverse, because it's sine, so we do sine inverse. And in here, something really important for reference angles,
That's positive.
always has to be positive. So I go to my calculator, and I go sine inverse of 1/3, and I get 19.471 degrees.
So how many decimals should you take it out of the calculator?
If it doesn't say, I always go 3 decimal places, but usually I'll say round to the nearest hundredth, 2 decimal places, 3 decimal places. But if it doesn't say, I'd say go 3 decimal places. On the grade 12 provincial exam, they require you to go to 3 decimal places if they don't say. If you go to 2 decimal places and they don't say, they take off a half a mark. I'm like, I would like if they just would say every single time, go to 3 decimal places. If that's what they want, why don't they say it? Okay, so we get a reference angle. So now you have to figure out the actual angles. Here, does it make sense that you would go 180 plus your reference angle? And here, I would go all the way around 360 and then subtract my reference angle. And that will solve for theta, so I can go to my calculator. 180 plus my reference angle, and get 199.471 degrees, and 360 minus my reference angle, 340.529 to 3 decimal places. So you're going to get questions that deal with reference angles. Okay, I could just give you an angle. If I gave you 123 degrees, what's the reference angle?
Probably like
You could draw it out.
57.
There's your 123 degrees. So how would I figure out this angle? I would go 180 minus this, right? And your reference angle would be 57 degrees. So I'm going to ask you questions about reference angles.
Special triangles, 30, 60, 45.
Yes, special triangles. Do you know your values without a calculator?
This is
Here's a special triangle for 45. If they're 45, these sides are the same. You can pick any number you want. If you use 1, you'll get 1, 1, and root 2. If you use 2, you get 2, 2, and root 8. Opposite over adjacent, 1. Opposite over hypotenuse, 1 over root 2, but we've already learned the unit where we have to rationalize our denominator. You get root 2 over 2. And you could get the same with cos. And then the 30, 60 special triangle, if you redraw it, it makes it an equilateral triangle. So you could pick any side length you want. We chose 2 because then that broke this up nicely to 1 and 1. You could pick 1 and then you'd have 0.5 and 0.5, but a squared plus b squared is harder with decimals. And if I did a squared plus b squared equals c squared, I would get the square root of 3 there. Then I can do sine of 30 degrees. I look at 30. Opposite side would be 1. Hypotenuse, 2. And I could get all of my answers for each of these from there. Okay. Next. I could give you a random point anywhere. So let's say I pick 5, -3 is my random point. If I made that point, I could draw a terminal arm through that point.
Does that have to be an arrow?
Yes, because that terminal arm keeps going forever. I am going to ask you a whole bunch of things about this.
Why?
Okay? I could ask you what the angle is. There. That would be your reference angle. I could ask you the angle in standard position to go there. I could ask you what sine of the angle. Okay. So, let's say I asked you what sine of the angle is. You would need to know opposite over hypotenuse. Do I know the opposite side? Yes. Its length is 3 because I've gone down 3. Do I know the adjacent side? Yes, it's 5. But I don't know the hypotenuse.
We can figure it out.
But we can figure it out with a squared plus b squared equals c squared. And you'd get square root of 34. So if I asked you what sine of theta is, you would be able to say that it is the opposite over the hypotenuse. And I would almost get it right if I wrote this.
It should be negative.
But it should be negative because according to your cast rule, if you're in quadrant 4, sine is negative. So some people, like, I'll add it in purple. Some people write the 3 because it's going down as a -3. I write the 3 as positive because I still think of it as a length. And then I always use the cast rule in the end, just like double check. Should it be positive or should it be negative? And in quadrant 4, only cosine is positive. So sine should be negative.
Should we do one of the double triangle cases?
Positive. Okay. first let's finish this up. If I wanted to find the reference angle or the actual angle, I would have probably used tan. Because the numbers were given to me and they're opposite over hypotenuse. Tan is negative in quadrant 4. I would get negative 3/5. My reference angle, tan inverse of positive 3/5. And then I'd go to my calculator. And 30.964. And so my actual angle would be 360 minus this. 329.036. So you're going to get situations like this with points in different quadrants, and I could give you a bunch of different information. I could just give you the point. And then you can find the hypotenuse, then you can find the angles, then you can find all the ratios. Sometimes I give you the ratio. I could give you the angle. Pick an angle.
67.
67 degrees in quadrant 1. I could give you one of the lengths.
5.
5 for which one? Side, hypotenuse, the opposite side? The adjacent side is 5. Tell me what that point is. Well, you told me the 5, so that you made it easier, right? You know that has to be 5, right? What do I need to find the y? I need to find that length. So you're going to have to use sine, cos, and tangent. Which one did you use, sine, cos, or tangent? Tangent, because you have tangent of 67 equals y over 5. So you could get any sorts of questions with quadrants. Sometimes I might ask you to find the points. Sometimes I'm going to ask you to find the angle. We'll have any of those. Okay. And pick 3 letters.
ABC,
Oh, other than ABC, just so it doesn't match up our formulas perfectly.
EXY.
E, X, and Y. Okay, this is angle E, this is angle X, and this is angle Y. All right. This is triangle XE. So, can we use SOHCAHTOA? No, not at 90 degrees. We can solve for one thing on this triangle with the sine law. What would it be?
X, Y.
From X to Y. And if we were using a little letter opposite at angle E, it would be side E. Why? Because the sine law always goes angles and opposite sides. So the fact that we have an angle and an opposite side, this allows us to use the sine law. Then, the other thing we knew was the 97, so it tells us the only thing we could solve for at this moment, well, technically you could find this angle because they add up to 180. But if you wanted to use the sine law, that 97 says you can solve for E. How do we use the sine law? Well, whatever you want to solve for, put that in the numerator of a fraction. And so E would go with sine of 97. And then we're putting sides on top, so the 8 would go with sine of 32. How do we solve this? Well, we get the e by itself. 8 sine of 97 over sine of 32. We type this all into our calculator, and you'd get the value of e. $14.984. So this is a regular sine law question where you're given a triangle, find a side, only one triangle is possible. But there are the two triangle questions with the sine law. How do they show up? Well, I give you a triangle. Triangle, 3 new letters.
C, B, and G.
CBG. Triangle CBG. And I tell you something like angle C is, I don't know, 40 degrees. Side from C to B is 7. And side from B to G is 6. So usually when they give you the information like this, not always, but when they don't draw the triangle and they give you the information, the reason they're not drawing the triangle is because that would give away there's only one triangle. So they don't draw the triangle, and you have to determine from here that there's going to be maybe one, maybe two, maybe no triangles. So what I like to do is whatever I'm drawing it, I make my angle here at 40 degrees. Then I would put B up here because we know C to B is 7. And where could G be along here? Can you see that G could be possibly here? But since this side is smaller than this one, it could swing around. Maybe there's two triangles. We don't know yet. Maybe it's 0. 6 seems pretty plausible for 2. I kind of imagine that length hitting twice. But I don't know. It could be 0. It could be like, because I could make this angle 89 degrees and then 6 would never hit. But for 40 degrees, I think there's going to be 2. How do I determine that there is going to be 2? Well, I start by saying I could use my sine law because I have those two together, which means with my sine law, I could solve for angle G. If there was 2 for angle G, there'd be 1 there and 1 there. But how do we determine if there's 2? What does the math look like? Well, we set up our sine law. So I want to find for angle G. So since I'm finding the angle, I put sine of G on the top. That's going to be over 7 equals sine of 40. That's going to be over 6. And I can get sine of G by itself by multiplying both sides by 7. I go to my calculator, I type this in, 7 sine 40 divided by 6. And on my calculator, I get 0.4. There's a bunch. 0.74. It's positive, so according to my cast rule, it could be in quadrant 1 or quadrant 2. I find my reference angle by doing sine inverse. My reference angle for G would be sine inverse of this number. My reference angle is 48.583. Well, since it's positive, one of the answers will be in quadrant 1.
131.3
The other one, 131.417. Usually these questions are nice and they say round to the nearest degree to make your life easier, right? So I'm gonna just imagine 49 degrees and 131 degrees for now. And I'm gonna go back to my picture. Almost, the announcement's almost coming through. Do they both work?
Yeah, they.
Announce if you're still in the hallway, get to the office. Announce if you're in the hallway, get to the office. Thanks.
I would run if I were him. Do you go to the hallway now? After? Okay. You can go. They both work. So there's two triangles possible. So I'm going to make a note here. And once they both work, I would draw both of them. So we've got 40 degrees. What were my numbers originally? 7, 6. And 131 degrees. So once you know both of them work, draw both separately. One with the acute angle of 49, that's going to be the bigger one, and then the obtuse one with 131. I draw a line now, because now I'm going to solve both of these, the rest of this triangle, to figure things out. If I wanted to find the other angle in this one, this is 89,
91.
that's 91 degrees. If I wanted to find the other angle in this one, this is 171, that's only 9 degrees. If I need to find this length on this one, right, it's opposite the 9, that's little b. So I use my sine law, little b over sine 91 equals, and I could use either one, however, it's recommended that you use the original ones so we don't use as much rounding. Question?
Do I have two possible angles and two possible triangles with that if I get two positive angles which are different?
If the two angles both work, so again, I went back up to my original here,
Yeah.
and when I said, okay, it's 49 or 131, they both are under, if I add it to the 40, they're both under 180. Sometimes the bigger one doesn't work because they don't add up. And if there's going to be no answer, maybe I'll just make one that has no answer so you can see what happens on your calculator so you don't freak out after we're done this. But yes, if both of them work, you have to do both triangles and solve for everything on both triangles. So on this one, b is going to be 6 sine 91 over sine of 40. .3. And over here, B, label C, B, and G again. B is going to be over sine of 9 degrees equals 6 over sine of 40. So B is equal to 6 sine 9 degrees over sine 40 degrees. .46. Something that always happens in triangles. The biggest side, see if this logically makes sense to you. the biggest side is always going to be opposite the biggest angle. So in this one, the 91 is obviously the biggest angle, 9.3 is the biggest side. In this one, the 131 is the biggest angle, the longest side is opposite, it's the 7. Smallest angle goes with smallest side. Yes.
So if I would use my sine law and stuff, and then I would get an angle that adds up with the angle I already have to over 180,
Mm-hmm.
that wouldn't work.
That's right. Then you would only have the one triangle.
Yeah.
So, and if you were, I'm going to give you one here. Let's say I gave you the stuff and you started drawing it out. And you drew it out, and they told you this was 31 degrees, this was 9, and this was 4. Okay? So you're thinking, oh, maybe the 4 swings around. Maybe there's 2 of them. I need to check. Well, do I have enough information for my sine law?
Yes.
Yes. I would be able to find this angle first. So if I want to find that angle, let's go with triangle. Ooh, should we make it a? We'll make it a car. Oh, vroom, vroom. Okay, so we can find angle R. So sine of R over 9 has to equal sine of 31 over 4. So again, I can find this in my calculator. I get 1.15. It's positive 1.159. So this is what I'm thinking. I see that it's positive. I'm thinking quadrant 1 and quadrant 2. I go to find my reference angle, but when I go to my calculator and I go sine inverse of my answer, I get an error. And that error is telling me that actually 4 was not long enough. Technically, I guess 4 was only this long, and it would never hit that side. But just giving you the idea that if you're using your calculator and you got that error, that's telling you there's no solutions, there's nothing possible. In fact, you could have already told me that from here. Do you know why it's not possible when I have sine R equals 1.15? It's bigger than 1. Sine is a ratio, like I can make that into a fraction over 1, and that would mean I have a 90-degree triangle where the opposite side is 1.15 and the hypotenuse is 1. That should bother you, because the hypotenuse is always the longest side. So anytime with sine or cosine, if you get something bigger than 1, it'll always be not possible when you go to your calculator. So that's the stuff that we've learned quite a bit in trigonometry, wouldn't you say already? Okay, so definitely sine law is going to be on there. Knowing how to tell if there's 0, 1, or 2 triangles from this, and solving it and drawing them both.